In this video, we will talk about limit-based continuity, graphical and analytical approaches. When in calculus you hear the word continuity or continuous, then make sure that you remember your three conditions. Either continuity, continuous, you need to have three conditions, and I'm going to give you those three conditions. In those three conditions, if any one of the condition doesn't meet, then it means the function is not continuous. So this is my graph. For the function graph below, fill in the table with the given information. After filling in the table, write three pieces of information that must be true in order for a function g of x to be continuous at x equal a. So, okay, they said answer these questions down there, then write down three conditions. I'm going to write three conditions first, and then we'll solve the question. Okay, the first condition. For example, this is my function f. So I can say the first condition is f of a must be defined. What does define means? Define means when you plug in x value in any function, you will get y. Like it's a closed circle, it's not a hole. For example, in this graph, if you guys pay attention, this is a hole. That's a closed circle. That's hole, hole, closed, and these are holes, and this is a closed circle. And if I pick a point up here, like this point, you know that's a closed circle because there is no hole in there. So obviously, if I pick this point, that's a hole. Pick this point, it's a, I'm sorry, not a hole, a defined point. This is a hole, defined point. Defined point means when you plug in x value, you should get a y value. For example, if I plug in -4 in the function, you know my y value is 3 for sure because you know it's a closed circle. If I plug in -6, you know that's a hole. It means I don't have a y value for this -6. It's undefined because it's a hole there. It's not really a y value. Okay, don't get confused yourself that, oh, you talked about arbitrarily close. Arbitrarily close I talked about when I'm looking for limit. Like if I'm saying limit x approaches -6 from the left and a limit x approaches -6 from the right, then I go to arbitrarily close. Arbitrarily close means I'm gonna say it's 4.99999 or something like that. So it's rounded up to 5, right? But actually I don't have a point there. So that's what define means. Next, second condition, limit x approaches a of f of x must exist. Must exist. So these are the three conditions that we have to have, these three conditions in order to say the function is continuous. Exist, which means limit x approaches a from the left of f of x is equal limit x approaches a from the right of f of x, and both left and right limit is equal the same y value. In this case, I'm just gonna say L. Okay. So, third condition that we have, this f of a, the point right here, defined point, like whatever the y value for that, is supposed to be equal limit x approaches a of f of x, and both of these supposed to be equal the same y value. I will explain these three conditions will make more sense once we do these questions right here. Okay, I'm gonna fill out the table. They said x equal -6. Is the function defined? If so, what is its value? Defined means when it's a closed circle, and what is its value, which means I'm looking for a y value when I plug in -6. So this is my -6, right there. No, that's -5, sorry. This is -6 right there. So -6 y value is going to be undefined because it's a hole. They are only asking a defined point. They're not asking limit. So no arbitrarily close. Arbitrarily close goes with limit. So it means I don't have any y value there. So I'm going to say the g negative 6 is equal undefined. Undefined, it's a whole, so undefined. Okay, what is the value of limit x approaches which means x approaches negative 6 from the left? So I'm going to say limit x approaches negative 6 from the left of g of x. So let's try that. This is negative 6 and I'm talking about left, right? So this is negative 6 and that's the, I mean, we don't have a y value, but we can find limit from the left. This is the left side of my negative 6. So when I approach from the left, I'm gonna get close to this, like right here, but I don't have like exactly getting to the y value of negative 6. So I'm gonna pick arbitrarily close. So this is gonna be, for example, 6.0001, you can say. So when you round it up, it's gonna be not 6, I'm sorry, 5. So it's gonna be 5. So when you round it up, it's going to be 5 from the left. So I'm going to say that's equal 5. What is the value of limit x approaches negative 6 from the right of g of x? What is the value of this? So this is negative 6. I'm going from the right. This is right side of negative 6. So if I'm going negative 6, I stop here and I'm going to pick arbitrarily close, which is again 5. So do you see, guys, the limit does exist? Like the limit from the left and limit from the right is exactly the same value. So it means the limit exists. But these two, this condition is good, limit exists. But the problem is step number 1 and condition number 1 and condition number 3 is not okay, because first of all, the point has to be defined, which is not defined. So I can tell limit x approaches negative 6 of g of x from left and this means left and right both is equal 5. So the limit exists. Is g of x continues at x equal negative 6? No, because these two conditions are not there. I can meet only this condition, the limit exists, but not the first and third. So it doesn't work. So it's not continuous. And you can tell it's not continuous. It's a whole, guys, right there. So it's not continuous. Okay, let's do x equal negative 3. And I'm using this graph right now because the other one, we can't see it. So I'm going to go limit x approaches negative 3 from the left of g of x. No, I'm sorry, this is not the limit. This is actually a defined point they're talking about. The first column is the defined point. Okay, so negative 3. So here is, I can say that's no. Okay, let's try. G of negative 3 is what? So this is negative 3 right there. And the y value at negative 3, I'm going to pick this one. That's a defined point. That's a closed circle. I'm not going to pick this because this is not a defined point, right? So no, this is not a y value, but this one is. So it's going to be equal to. Let's try the limits. Limit x approaches negative 3 from the left of g of x is equal. So this is negative 3 and I'm going to go left. This is my left and I approach exactly at this point, which is 2. So my limit from the left is 2. Now we're going to go limit x approaches negative 3 from the right of g of x. So let's try right. And you guys can tell this is negative 3 and the right side is this, right? So in the right side, I'm going to pick this piece of the graph because this is the only right side graph that is approaching negative 3's y value, right? So when I approach from the right side, I stop right there as an arbitrarily close. And when I round it up, it's going to be negative 4. So this is negative 4. You see the left and right limits are not the same. If they're not the same, limit does not exist. Now again, you see my first condition, my first condition is okay, but my second and third condition is not there. It's not working. So it means the function is not continuous. And you can tell it's not continuous because it's a jump. Look, it's a jump. It's not continuous. Okay, then we can do g of 0. What is g of 0? So here is the 0. I'm going to use a different color. So I wanted to use different colors. So this is g of 0 equal. So here is the 0. Here is the 0 right there. When x is 0, what is the y value? So I'm not going to look up here because I don't have a graph there. I'm going to look down here, and this is -1. When I have my x is 0, my y value is -1. So done, it's defined. Let's try. Limit x approaches 0 from the left of g of x. So this is my 0, and I'm going from the left. Left graph is that one, right? So if I go from the left, I approach where my y value for 0 is, it's -1. So I'm going to say it's -1. Limit x approaches 0 from the right of g of x is equal. So that's my right, and I'm approaching 0, and the y value for 0 is again -1. Okay, this one perfect. Look, limit exists, and also my point is defined. And my third condition, according to my third condition, this point, defined point, is supposed to be equal the limit. So in this case, I'm going to say limit x approaches 0 of g of x is equal -1. Is the function continuous? Yes. At 0, my function is continuous, and you can tell at 0 my function is continuous because there is no hole, no jumps, nothing, breaks, nothing. So yes, and my three conditions are there. Now, look, the first condition, the point has to be defined. It is defined because I plugged in 0. I got -1, not a hole, it's a y value. Then the limit should exist from left and right both. So limit exists left and right, limit exists, it's -1. Third condition, the defined point y value, which is -1, and the limit y value, which is -1, supposed to be equal. So yes, it's continuous. Let's try x equal 2. Now, what is g of 2? G2 is right there, that's 2. Now, can you guys see if there is any y value when I plug in 2? No, because I have a vertical asymptote at 2. Do you guys see that? And there is no graph that I can say, okay, I plugged in 2 and that's my y. No, there is no graph. So I'm going to say that's undefined. When I see the undefined or I don't see the defined point, then it means I can tell clearly that, okay, it's not going to be continuous. Okay, but let's try. Then we have to give them three conditions no matter what. Limit x approaches 2 from the left of g of x equal. So that's my 2, and I'm talking about left. Left is this portion, right? So when I'm approaching to the y value of 2 from the left side, and that's the left side I'm approaching, and do you see the y value is continuously going in this direction? It's not going to cross the vertical asymptote 2, but it's going continuously, which means it's going, the y value is going to positive infinity. So this is my positive infinity. Limit x approaches 2 from the right of g of x equal, that's 2, and my right function is right here, and this is the right function that approaching 2, and it's going to continuously going in this direction, which means that's a negative infinity. Now this is positive infinity, this is negative infinity, limit does not exist. In any case, guys, when I approach, even if I would get limit from the left, positive infinity, limit from the right, also positive infinity, it doesn't mean the limit exists, because the infinity is not a real number, and for limits we need a real number, like a real y value. So in this case, I just straightforward said does not exist. This is a positive infinity, negative infinity. In case if both of them were positive infinities, though, I would say positive infinity, right? Positive infinity, and I'll put that does not exist in bracket. So to be on the safe side, I'm telling them that's what I mean. It is positive infinity because both are the same, but infinity means does not exist. So I'm going to erase that from here. Now, since this is infinity undefined, so the function is not continuous because you can tell it's a jump, it's not continuous. X approaches 6. What is the 6? Y value. This is 6 and Y value, look, this is what I have. One of the thing is right there, one of the thing is right here on 6. But you do know these are two not defined points. They are not Y values. This is the only point that I'm talking about is a Y value, and it is 1. Then I'm going to go limit x approaches 6 from the left of g of x. So this is 6, I'm going left, and on the left side of 6 is all of this side. And I'm going to pick this piece of information because this is where I'm approaching y value of 6. So I'm approaching this from the left, and I arbitrarily close up here. I stopped, and arbitrarily close is going to be positive 4. I can already tell it's not continuous because you see the defined point in the limit. So limit x approaches 6 from the right of g of x equal. That's 6, and I'm going in right, and arbitrarily closes right there, and again it's negative 2. So limit does not exist because limit from the left and limit from the right are two different y values, so it does not exist. And another thing, my defined point is not the same, like not all the conditions are meeting, so no. Then I'm gonna go g of 8. This is 8, 7, 8 right there. So the defined point at 8 is this, which is negative 4. So let's see, limit x approaches 8 from the left of g of x. So this is 8, and I'm going left. Left is right there, and I'm approaching to the y value of 8. So this is arbitrarily closed, which is negative 2. Limit x approaches 8 from the right of g of x equal. Right is right there, and I'm getting to arbitrarily close, and again it's negative 2. The limit does exist actually, but the limit and the defined point are not the same values. So I can say limit x approaches 8 of g of x. Do you see I don't have the signs positive and negative, which means I am talking about both. Negative 2 is good. But is it continuous? No, because the defined point in the limit are not the same. Okay, so this is how we are dealing with all of this. Let's try this. The graph of the function g of x pictured below has several x values at which the function is not continuous. For each of the following x values, the three-part definition of continuity to determine if the function is continuous or not. Three-part definition, that's exactly what I'm talking about, the three conditions that has to be defined point, limit must exist from left and right, in the defined point in the limit has to have same y values. Okay, let's try. Now, in this case, x equal negative 8. So my negative 8 is right there. This is negative 8. So my three conditions. So the first condition I have, and this is how exactly you would do my free response question. If this was free response question, no matter what, I have to give them the three conditions. When I see the word continuous or continuity, I have to do the three conditions, okay? So this is negative 8, and the function, what is the function? G of x. Okay, so I'm going to use g of x. So I have the first condition is a defined point, g negative 8. At negative 8, do we have a defined point? I don't think so. It's a hole, so it's not a defined point. Do we have up there? Oh, yes, we do. Look, right there. That's a defined point at negative 8, which is 4. So I'm going to equal 4. Second condition, limit from left and right. So let's do limit x approaches negative 8 from the left of g of x. It doesn't matter you do left first or right first, okay? I don't know why I just did left. So this is negative 8 from the left, and this is negative 8, and left means I have to look for the graph on the left. I'm approaching the y value of negative 8. The y value is not there, but I can go arbitrarily close, and that would be negative 5. Then I'm going to go limit x approaches -8 from the right side of g of x equal. So this is right side of -8. I'm gonna go and pick this and go arbitrarily close right there, and it's -5 again. So in this case, limit does exist actually. Okay, so now let's see the third condition. According to the third condition, g -8, like this, supposed to be equal limit x approaches -8 from left and right of g of x. So you know the third condition is not there. We are not meeting the third condition because the limit and the defined point, the limit is -5 and the defined point is 4. They're supposed to be exactly the same y values, in which in this case is not. So what I'm going to do, I'm going to say not equal each other. Like -8 is not equal limit x approaches -8 g of x. So these are my three conditions. Now, I'm going to say, and they are asking for explanation. So therefore, and I'm using these three dots. You can use these three dots on the test. Therefore, g of x is not continuous at x equal -8. That's all. And because they are asking me determine if the function is continuous or not, so I have to give them the reason that's why it's not continuous. Okay, let's try question number 2, the -6 part. Okay, I'm going to use a different color. First condition, g of -6 equal. So this is -6, and I don't have a graph up there or any point, but -6 y value is right there, and it's a defined point. It's -7. Then second condition, limit x approaches -6 from the right of g of x is equal. So that's -6, -6, and this is the only graph that we have that approaches -6 is y value. So I'm going to go right of -6, and I approach right there. The y value is -7. Limit x approaches -6 from the left of g of x is equal. This is -6 from the left is right there, right? And again, it's -7. Now, do you see? -7, -7, -7. We are okay now. The third condition, I can say g -6 is equal limit x approaches -6 left and right of g of x is equal -7. Now the function is continuous, and you can tell it at -6 the function is continuous. No holes, no breaks, no jumps. So I'm going to say, therefore, g of x is continuous. All my three conditions, we met three conditions. G of x is continuous at x equal -6. Done. Let's try x equal -4. So first condition, g -4 equal. This is -4, and this is not that's a hole, that's not a point. We're not talking about limit, we're just talking about a point. So, but this is -4 point, which is -5. Second condition, limit x approaches -4 from the right of g of x is equal from the right. So this is -4, and this is the right side of -4, and this is the only one graph that is approaching -4's y value, and I'm going to pick arbitrarily close because that's a hole, and arbitrarily close is -2. You can tell it's not continuous because of this. I already got different ones. Limit x approaches -4 from the left of g of x equal. So that's -4, and this is left side of -4, and the only graph that I have is right there on left of -4. So I'm going to start and approach -4 right there. And since it's a closed circle, then I just like move my arrow on top of this because it's a y value, -5. Okay, so you can tell limit does not exist because left and right limits are different. So I'm going to say third limit g negative 4 is not equal limit x approaches negative 4 of g of x, and also you can say limit x approaches negative 4 of g of x is equal does not exist. I'm supposed to have this first, then I have that. Then we have therefore g of x is not continuous at x equal negative 4. So it's done. Let's go to these two questions. They said use the three definitions are continuous and indicated values of x. Now this is we did graphical, all of them we did graphical approaches so far. Now we're going to do analytical approaches, like we're going to use our functions to figure it out how to do that. Okay, first thing first, and I'm talking about x equal negative 2. Okay, so the first condition is, and this is f of x, so f of negative 2, if my x value is negative 2, what is my y value? Now you have three different pieces. Do you guys see this is three different pieces? This one, it says x less than negative 2. Now this works for less than negative 2. This one works for greater than negative 2. But this one is x equal negative 2. So it means I'm going to use that one. So 3x plus 2. So I'm going to plug it in. 3 negative 2 plus 2 is going to give me negative 6 plus 2. So it's negative 4 right there. So that's my defined point. Second, we're going to find limit. Limit x approaches negative 2 from the left of f of x. Now, from the left f of x, but I have two functions, right? I mean, I have this piece and I have this piece. This one was equal, so we're not doing that one. Left means when it's less. So this is less. If you read it from the variable side, x less than negative 2. So left is always less, left. And greater, x greater, or alligator mouth towards x, greater means that's right. So I'm going to pick this for left. So I'm going to plug in negative 2 there, okay? Negative 2 square root for the x, plug in negative 2 plus 6. This is going to give me negative 2. 6 subtract 2 is 4, and 4 is a perfect square, so it's going to be 2. So that's negative 4. Here we go. We got that one. Then we have a limit. X approaches negative 2 from the right of f of x equal. So for the right, I'm using that. So it's going to be, I'm already plugging in stuff, okay? E negative 2 plus cosine negative 2 pi as an argument. Okay, so how do I solve this? Okay, 2 pi cosine. You should have a unit circle, and you can tell 2 pi of cosine is going to be 1. I can show you my unit circle. It was somewhere up here. This one, I can grab it and move it down. Okay, here is my unit circle. Okay, come on. Okay, here we go. We're gonna need this, so I have to move it. Okay. There you go. Okay, we're good now. The color I was using, I guess, blue one? I don't know. probably that one. Okay, so this is what I have. So cosine 2 pi. You can tell this is your 2 pi right here, right? And the 2 pi cosine, I know it's negative, but I mean, negative and positive is not gonna do anything. You're gonna, on the unit circle, you're gonna see it like that. 2 pi is 1. So I have equal e negative 2 plus cosine, I'm sorry, not cosine, it's gonna be just 1 right there. Now e negative 2 is not acceptable, so it's going to go 1 over e2 plus 1. I mean, whatever I'm getting from here, you can tell it's not equal negative 4. It's not going to be equal negative 4 because e value is 2.777 something. I don't remember, but it's 2.7. You plug it in the calculator, you will see it. But it's not going to give me negative 4. So it means the limit does not exist. Limit x approaches negative 2, f of x is equal does not exist because limit from the left and right are not the same. Like this is negative 4 and this one is 1 over e squared plus 1. Now third condition was if the defined point and limit is the same. So I know it's not the same, so I can't give them the third condition, but if you want you can write it down. F negative 2 is not equal limit x approaches negative 2 of f of x. And I think we don't need this because if the limit doesn't exist, then I cannot say it's equal or not equal. So I'll just stop when the limit doesn't exist. I should stop at 2. Okay, now I have to explain why it's not continuous. I have to give them a reason. I'm going to say therefore f of x is not continuous at like justification, like I have to say it. It's right there. F of x is not continuous because, not because, is not continuous at x equal negative 2. So, I mean, I don't have to give them this third condition because if its limit doesn't exist, then what's the point? Okay, let's try question number 5. In question number 5, the first condition is g of pi for the defined point. So this is pi. Now this is less, that's greater, but you do understand this means equal. So I'm going to pick this whole thing for the equal. So I'm going to plug in e pi tangent 3 pi over 4, right? So it's going to give me e pi tangent 3 pi over 4. Tangent is, since we don't have tangent on the unit circle, then we are going to use sine over cosine. So I'm going to use sine 3 pi over 4 over cosine 3 pi over 4. Now let's figure it out. Equal e pi is going to stay as a e pi. Sine 3 pi over 4. Where is 3 pi over 4? This is 3 pi over 4. The sine is a y value, so square root 2 over 2. Square root 2 over 2. Divide by cosine 3 pi over 4, which is negative square root 2 over 2. I can simplify this further. E pi, and I got square root 2 over 2 times, I'm going to flip negative 2 over square root. Since when I change to multiplication, the division I change to multiplication, I have to do reciprocal. Cancel, cancel. So I got negative 1. So my answer is negative e pi. That's my point, the defined point. And I don't have to go further, but I just know it's e negative pi. Okay, let's second limit x approaches pi from the left of g of x. So left means less, right there, less, g x less than pi. So I'm using this portion for the left. So e pi cosine pi. So what's this going to give me? E pi is going to stay e pi. cosine pi. This is my pi. Cosine is x value, which is -1, so it's going to be negative e pi. Okay, cool. Now I have limit x approaches pi from the right of g of x. For the right, I'm using this portion. So we already got that one actually. E pi tangent 3 pi over 4. So we already got this one right here. So I don't have to do this all over again. I know it's negative e pi. So can you guys see this? The defined point is negative e pi to the power to the power pi, negative e to the power pi, negative e to the power pi. So it means the limit x approaches pi of g of x is equal negative e pi. Now the third condition, we said g pi supposed to be equal limit x approaches pi of g of x, and both of them are equal negative e pi. They have the same y value. It means therefore g of x is continuous. I'm not writing the whole thing, at x equal pi. So that's how you answer that question. Okay. Now let's try some question number 6, what they're talking about. Consider the function f of x to the right to answer the following questions. What two limits must equal in order for f of x to be continuous at x equal -1? What two limits? It means I'm talking about limit from the left and limit from the right. Like, you know, obviously that these are the only two limits we have. Limit x approaches -1 from the left of f of x equal limit x approaches -1 from the right of f of x. So they're supposed to be equal in order for us to say the function is continuous. What two limits must equal in order for f of x to be continuous at x equal 3? Again, the same thing. Limit x approaches 3 from the left of f of x. Limit x approaches 3 from the right of f of x. Now you guys can tell these are two negative, like x less equal -1, x greater -1. So this is right and that's left. For the 3, this is left and this is right. Okay. Determine the value of m and k so that the function is continuous everywhere. Now, I know that we are looking for m and k. So the easy thing to do is, I know already, let's figure it out, the x -1 first. So I'm gonna go, I know, let's try. Okay, x equal -1 is equal 2. So I'm gonna say 2 is equal m -1 is an x value, like I'm talking about -1, 2 as an order pair right there. This is negative, this is equal. So -1 is equal to, for the x and y, plus k. The other portion for the 3, I know this order pair, like 3 and -2, right? So I'm gonna say -2 is a y value, m and x is 3 plus k. Now what I can do, these are my two equations, and you can use system of equation to figure it out, the m and k. Now, since they said its function is continuous everywhere, so you can apply limit x approaches -1, all the three conditions, and you will end up something like that anyway. So I'm going to make them equal each other, the two equations, and see if we can solve it as a system of equations. So this is 3m plus k. So I can, what I can do, I can multiply this first equation with -3. If I multiply this with -3, I know m and m will cancel out. So let me try that. I'm going to go -6 when I multiply equal, not -3, I'm sorry, +3, because this is already negative. So this is system of equation that we used to do in algebra 2 and algebra 1. So 3 times 2 is 6 equal 3 times -1 is -3m plus 3k. The other equation is right there, negative 2. I'm not doing anything with that one. Plus k. So this one cancel out. Now I'm left with 4 equal 4k. Then you divide 4 both sides and it will give me k equal 1. So I got a k answer. Now I have to plug in this k in here to get the m. And we already know the x is, I mean, you can tell the x is 1, or you can plug it in any one of those, if whatever is making sense. So if I plug in this k equal 1 in this equation, and I'm going to say negative 2 equal 3m plus 1. Subtract 1 both sides. It's negative 3 equal 3m. You divide 3 both sides, and it's going to give me m equal negative 1. And this is how you solve the variable if you have any in the question, like k and m. You can make them equal these two each other, and you can make these two equal each other. And you know, if I'm talking about these two, I'm talking about x3. If I'm combining these two, I'm talking about negative 1. You can always remember, when you're looking for the variable in piecewise function, variables are missing in the piecewise function, then make equation equal each other. If x is given. If x is not given, I'll show you how to do those later, not now. Okay, let's try question number 7. Consider the function g of x to the right and answer the following. What two limits must equal in order for g of x to be continuous at x equal negative 2? Again, the same thing. Limit x approaches negative 2 from the right of g of x is supposed to be equal limit x approaches negative 2 from the left of g of x. Must equal unit to be continued at x equal 3. Again, the same thing. Limit x approaches 3 from the right of g of x is equal limit x approaches 3 from the left of g of x. So then we are okay. Now let's find out the m and k. Again, I told you guys before, this is negative 2 and negative 2, right there. So these two equations we are using for negative 2. Now for 3 and 3, I'm using these two equations for 3 and 3. So let's use the yellow one first, the 2. So I'm going to make them equal each other. Kx squared plus m equal 4x plus 1. Since the x is already given negative 2, I'm going to plug in that. Negative 2 squared means 4k, right? Plus m equal 4 times negative 2 is negative 8 plus 1. So that's negative 7m plus 4k. So I got first equation right there. Let's do the second one. I'm going to make these two equal each other. 4x plus 1 equal kx minus m. And x is given, which is 3. 3 times 4 is 12 plus 1. K is 3k minus m. I don't have m. That's 13 equal 3k minus m, and that's my second equation. Let's put them together and see how it goes, and I'm going to put it exactly, let's put the yellow one here. Negative 7 here, 4k up here, plus m here. You see m and m, I can cancel them out, opposite signs, so I don't have to multiply or change any of my equation. So 13 subtract 7 is going to give me what? 13 subtract 7. 7 is going to give me 6. So I got 6 up here. 4, 5, 6, 7k. So you divide 7 both sides and it's going to give me k. K is equal 6 over 7. Done. Now let's figure it out. Plug in this k in one of these equations, either this one or the equation 1 and 2, and find out. So I'm going to plug it in here. K equal 4, 6 over 7 plus m equal negative 7. So 6 times 4 is 24 over 7 plus m equal negative 7. you subtract 24/7, you subtract 24/7, and m is equal. Since I have one fraction, I don't have another one, so I'm gonna make a least common denominator. So what I'm gonna get, 7 times 1 is 7, and negative 49 minus 24. So 49 and 24, you add them and keep the sign. It's going to give me negative 73 over 7. And I cannot simplify this further. Okay, so this is what we got for the things. And like I said, if you have piecewise function, variables are missing. If x is given, make them equal each other. Okay. Please subscribe, share, like, and if you have any questions, please comment below. I would be happy to answer your questions. Thank you and bye.